Hello and welcome to this second lecture of Excellence in Problem Solving, where we're going to talk about the problem solving methodologies in building excellence in problem solving. As you know, my name is Arun Singhal. I'm your management coach and mentor with 40 years of experience in people development. So, what are we going to do today in this second lecture? So the purpose of this module is to tell you about the various methodologies that we outlined in the first lecture that can help you build excellence in your problem solving. At the end of this module, you will learn what are the various methodologies we touched on in last session. When can you use each of these? We will go into a little more detail about these methodologies. How can they help you identifying the root cause of a problem? Because that's the excellence requirement, right? And what are the limitations? And I remember here one of my professors at IIM Bangalore, Professor Iyer, and he used to tell about all this methodology and then says you must know where they don't work. Right. So what methodologies can you use for problem analysis? Do you remember from the last session? Can you note down on a piece of paper? All right. So let me recap there. So basically there are 6 methodologies that we listed, and there are a couple of more that we will talk about. So there are these methodologies that we talked in the last session: KT analysis, 5 whys, Ishikawa diagram, Pareto analysis, fault tree, failure mode, FMEA, and we will take each of these. Let's start with the 5 why analysis. So what do you think is the 5 why analysis? Thinks the name describes it all? Have you heard about this? All right. Let's talk about 5 why analysis. The 5 why analysis asks 5 why 5 times. Example, for a problem that has happened. Example, car won't start, as you see on the screen. So you'll say, hey, okay, car won't start. Why? Why is the car not starting? And obviously someone would say, hey, there's a dead battery. Why is there a dead battery? That's the second why. Or didn't charge it. Okay, so why did the battery didn't charge? The third question, third why. Or the belt is slipping. The belt is slipping, so the battery didn't charge. Fourth question, why is the belt slipping? Oh, the belt is worn out. And the fifth could be, why is the belt worn out? Or didn't know how to change the belt. So what you see here in this process is, from a simple cause of car not starting, we're trying to find a root cause of the problem, which turns out to be training. Right? Okay. So when to use this methodology? So this methodology is to be used when, as you can see from the previous example, is that you must know the cause. Right? If your cause is unknown, you can't do that. Your process will stop. Second thing, this problem must have occurred in the past. That's why you probably know the causes, right? So the problem must be repetitive. And you must need to find the systemic cause. Let me go down to the bottom of the ocean and find out what is causing this problem. And that's where this is to be used. So when you want to find the systemic cause, when the cause is known and the problem is occurring again and again, that's where you use this so that the problem doesn't come back again. So how does this problem help you find the root cause and what are its limitations? So repeatedly asking 5 times why helps you go deeper into systemic levels. More the times you ask why, more you are going into depth of a problem, and you start define the causes that can you build solutions that can have more broader impact, more strategic impact. It doesn't only solve this problem. So once you start focusing on training in the previous one, it will not only avoid the problem of car won't starting, but maybe there are a lot of other things that we haven't trained our people enough that will prevent those from happening. What are the limitations of this methodology? Cannot work if the problem is occurring for the first time. If the problem is occurring for the first time, obviously you won't know the cause and the process will stop. You won't be able to proceed more than one why. Or people don't know the causes. Problem is occurring, but the cause isn't known. So this is important, that this methodology can only work when people know the causes and we can proceed to the next level of the causes, reaching the systemic level. So what is fishbone diagram or Ishikawa diagram? Heard of that? Anyone, what you want to note down? Okay. Ishikawa diagram or fishbone diagram looks like a fishbone diagram. In this, what you see at the head of the fish on the right hand side is example of a bad coffee. So you had a problem, the coffee was bad. Now, what it helps you do is it helps you think through what are the possible causes by looking at certain categories, like what are the procedures, or no training, too much water, too many grounds, wrong size filter. So the procedure. Then you look at people side. You can say and then you look at, okay, let me look at the people part. What possibly can be wrong in people? So people have no training, wrong coffee, computer not updated. Then you look at equipment, you look at materials, and like this, you find out the possible causes. So you get a sense of fishbone diagram. Okay. So when to use fishbone diagram? The fishbone diagram can be used when the cause is unknown, vis-a-vis the 5 why, where you need to know the cause. So in this case, you do not know the cause. And that's why you're saying, okay, let me go into certain categories like people, procedures, equipment, and material, and brainstorm and find out what are the possible causes. Problems could be repetitive or first time. So it doesn't matter really. And you want to find the possible causes. It doesn't go to the root cause problem. It doesn't help you find the root cause by itself. You need to use other methodologies with it too. It only helps you find the possible causes. By the brainstorming process, by looking at certain categories of possible causes, you brainstorm and look at and find the possible causes. So how does it help find the root cause? As I was saying earlier, it only helps you generate possible causes. You need to use other methodologies to find the root causes. By itself, it cannot find the root cause. You get that? Wonderful. What is Pareto analysis? Heard of Pareto analysis? Right. So Pareto analysis is the quantitative method in which you have a lot of known causes. And these causes the problem has been occurring in the past, and you have collected the data of either the impact or number of occurrences of the problem. And you know the cause for each occurrence, and you can then plot and say, okay, let me plot in a decreasing manner. What is the cause that accounts for most of the count of errors or most of the impact in a decreasing manner? And there you draw an 80% line, and then you say, okay, so what are the dominant causes that are causing the most of the problems, situations, or occurrences to happen or impact to occur? So that's Pareto analysis. So when to use the Pareto analysis? Many known causes. You know, and there are many known causes, small, big, and you have number of causes. And you don't know what is the dominant cause, which one to focus on. It's a repetitive problem. If it's not repetitive, you won't have data. So you need to have a repetitive problem. Defects on manufacturing. The same kind of defect keeps happening again and again and again. You keep producing Band-Aid, it comes out defective, and it's at a certain level of defects keep occurring. And you have data on the count or impact of the problem by the different causes, because then you can plot that data. How does help you find the root cause? It helps you identify few vital causes that account for majority, 80% of the problem occurrences or impact occurrences. When can you use this? You will need well spread out data to come to statistically valid conclusions. You must have ideally for each of the causes 30 sample size, because that's the valid occurrences. If you have any cause that is less than 30 occurrences, then you won't be sure of the data being statistically right. And if the cause is not known, obviously it won't even feature it, right? So unknown cause is completely outside the boundary of knowledge or analysis in this case, right? The next methodology is fault-free analysis. What is fault-free analysis? Fault-free analysis is again a process similar to a little bit similar to, but different from 5 whys. You start at the top with the car won't start, and then you say, okay, what are the possible causes? So either there's a control problem or there's an electrical problem. And if there's a control problem, is my car in the parking? And that's why it is not starting, or is if there's a foot on the brake, so car is not running through. Is it an electrical problem? Is it a starter problem, or is it a broken problem? It's a bit like for fishbone diagram, but the fishbone diagrams give you certain categories to think through. This is a more freewheeling brainstorming methodology. When to use the fault tree analysis? When the causes are unknown, you do not know the causes and you are brainstorming. The problem could be repetitive or non-repetitive, and you want to know the possible causes. How does it help you find the root cause? It only helps you find the possible causes. It cannot tell you the root cause by itself. You need other technologies, methodologies like either the Pareto analysis or 5i. 5i probably, maybe 5i can be used, but by itself it cannot tell you the root cause analysis. Right. Let's look at another methodology called FMEA, Failure Mode and Effect Analysis. This is a methodology that is used to look at the potential problem. It is a very advanced technique used by in the process controls by the QA people. So what they say is we look at possible failure modes, the things that can cause failures. Let's say A, B, and C, and then you say, okay, you see on each of these, you say, okay, what is the severity? 10 being highest, 1 being lowest. How do I rate? What is the severity of the impact of the failure mode happening? A. What is the probability of occurrence? And what is the probability of detection? And like this, you do in a group to arrive at a consensus, A, B, C failure mode. And then you arrive at what is called RPN, risk preference number. So you get for each of them, which is a multiplication of the severity, probability of occurrence, and probability of detections. Like 140 is arrived by multiplying 5 by 7 by 4. And you get the failure mode that is the highest RPN as the one that you need to focus. So when to use the FMEA? When the failure modes are known or possible causes are known, these are the things that can cause failures. And the problems are repetitive but potential problem. You don't have a problem on hand, but it can happen. And you want to prevent that from happening. And you want to know the causes that is causing maximum risk. You want to know the failure modes that is causing the maximum risk, and you want to address that. So that's where you need to use. How does it help you find the root cause? It helps you identify parts of the process, the failure modes of the process. If my RPN is higher for the mode A, then I say, okay, which part of the process is contributing to the failure mode A? And then you start analyzing that part of the process using other methodologies that can help you address that. And for that, you need a very good understanding of the process. Six Sigma, process excellence are some of the methodologies that are used to address the process. And this could include some of the methodologies in finding the cause, like Pareto analysis itself. There's another methodology that we haven't talked about, and this is the favorite of McKinsey, called MECE. What is MECE? MECE stands for Mutually Exclusive, Collectively Exhaustive Root Cause Methodology. The whole purpose is that if I have a problem occurring, can I find all possible causes, that means I don't leave out any cause that won't cause a problem. And second, each of the causes is independent, mutually exclusive, and collectively exhaustive. Right? You get that understanding of that? Example, if I'm looking at profit as a problem or an outcome, then I would say my independent MECE variables are revenue and cost. And revenue is determined by price in units and units sold, multiplication of that. Cost is cost per unit and unit sold, and similarly cost, etc., etc. So I determine MECE, what are my different variables which are mutually exclusive and collectively exhaustive that could contribute to the problem. When to use this? When my possible causes are known, because I cannot determine MECE variables till the time I know the drivers, the possible causes. It could be used for repetitive or non-repetitive problem. And when you want to know the all possible causes, you don't want to leave chance any particular cause, because the impact could be so high of a a neglected cause that you say, hey, I don't want to leave anything to chance. I want to know all possible causes. How does it help you find root causes? This helps you list all possible causes. Imagine you want to know what are the possible causes that is causing aircraft failure. Now you can't leave anything to chance there, can you? So you will use A, B, C, E there. And it depends on the knowledge of the team. It's very dependent on the knowledge of the team. If the team is not knowledgeable, you won't be able to find all possible causes. And as we mentioned, you need to use other methodologies to eliminate the causes to find the root cause of a problem when it is occurring. Okay. There's another methodology. Let's quickly look at that. It's an effect cause effect methodology, ECE methodology. ECE methodology helps you find the root cause of an undesirable situation. This is again a very powerful methodology, a qualitative methodology that can help you find the root cause of a problem. It helps you pinpoint the underlying causes of a problem also. And it persuades others by explaining the entire process of constructing ECB and providing the solid proof. So it provides the proof. If you say that if my revenue is the problem of profit, then why is that the revenue is the problem of the profit? And you are able to convince the rest of the people. And how do you do that? You hypothesize the reasons. You brainstorm, you think using the techniques or otherwise. And you say, okay, these are the possible, or this is one of the reasons that I want to test. So this is actually hypothesis testing methodology of so you hypothesize one reason or many reasons and you take one at a time. Then you say, if that is the reason, let me see what should it result in. So you derive the resulting different effects on that. And then you check if this is the reason, is it occurring in all the places? So if the cause is that same reason, and if the effects are existing all the places, then you say, yeah, this hypothesis is right. So this is an hypothesis testing methodology. When to use this? When the possible causes are known, then only you can hypothesize, you can make an hypothesis. It could be used in repetitive or non-repetitive problem, and you want to eliminate the possible causes. You want to see out of the three causes or three hypotheses, which one is right, which is the root cause of the problem. How does it help you find the root cause? It eliminates the possible causes by narrowing down to the root cause. You make an hypothesis. If the hypothesis doesn't come true, you eliminate that cause. And like this, you move forward. Does not need a lot of data. It needs a lot of logic. You say, okay, if this is my hypothesis, this is the result I should see. Let me go back and check, is this happening all over? Right? It works as well as the possible causes generated. So if you have not generated enough possible causes, and if you miss the right possible cause, it is possible that you will not find the root cause because you won't form that hypothesis, right? Let's talk about lastly a methodology called KT problem analysis. KT standing for Kepner-Tregoe problem analysis. And this is part of a larger methodology of KT that we will talk about. So this basically talks about describing the problem, identifying possible. So it is a very comprehensive methodology. It helps you define the problem, also helps you identify possible causes. Then it goes to evaluate the possible causes and find the true cause. So this is one methodology that has it all. You saw it that some of the methodology can only generate possible causes, some can only eliminate cause. So here is a methodology that can help you do all steps of the process. So when to use this? You should use this methodology when the causes are unknown and the problem is non-repetitive. Because if the repetitive problem, you have data, maybe you should look at Pareto. And you want to generate as well as eliminate possible causes, right? How does it help you find the root cause and what are its limitations? It helps you generate possible causes and also confirm the root causes. Does not need a lot of data. It needs knowledge, but does not need the data like the Pareto analysis. But the limitation is it depends on the knowledge of the team. If the team is not knowledgeable, you will not be able to make good use of this. So what did we learn in this module? So we learned that there are many methodologies that can be used depending the situation and requirement, like 5Y, Fishbone, Pareto, fault tree analysis, FMEA, MECE, ECE, and KT. Some methodologies like 5 and Pareto analysis can only work when the causes are known. We need to find either the dominant cause or systemic cause. That's where these methodologies work. Methods like fishbone diagram, fault tree analysis, MEC can only help us generate the possible causes. Need to apply other methods along with them to find the root cause. FMA works to prevent potential problem. It goes a step forward with the knowledge of the impact of different parts contributing towards the problem. ECE method can only help in eliminating possible causes and getting to the most probable cause. Only KT problem analysis is the one methodology, as I was mentioning, that offers a methodology that can help generate possible causes as well as eliminate the possible causes to find the root cause of the methodology. So where do we go from here in the next modules? So since KT is such a wonderful technique, and I was lucky to learn this in Unilever in my initial days, and I've stayed with this for my entire career, including till now. So I would like us to spend time in understanding the KT problem solving methodology in the next session that we're talking about. So thank you so much for listening to me about the various problem solving methodologies that we talked about in this module. I hope you have enjoyed knowing about the various methodologies that can help you identify the root cause, and also knowing under what conditions can you use any of them. So thank you so much. Look forward to seeing you again in the next module, where we will start learning about the KT problem analysis method.